Hello, I'm Bruno Taillé and I'm going to present our work on the impact of contextualized embeddings on name entity recognition. Contextualized representations from language model pre-training, such as ELMO or BERT, enable to improve state-of-the-art performance in virtually every NLP task. These representations, depending on the context, seem particularly helpful in name entity recognition for generalization to mentions never seen during training. In this work, we focus on this aspect of generalization to both unseen mentions and new domains. We show that the generalization capabilities of language model pre-training are underestimated because of an unrealistic lexical overlap in standard benchmarks. Let me first quickly introduce the name entity recognition task and the word representations we studied. NER consists in detecting words referring to certain types of entities, and it is often modeled as a sequence labeling task. The state-of-the-art architecture for sequence labeling is the BLSTM CRF, introduced in 2015. Later improvements mainly stem from new word representations. Here, we compare several types of representations. Lexical, with glove as our traditional word embedding baseline, morphological, with a learned character level BLSTM, or the character CNN in ELMO, we refer to as ELMO 0, and contextual with ELMO, FLAIR, and BERT, all derived from language model pre-training. Regarding ELMO, FLAIR, and BERT, let me highlight two key differences. First, in green, the architecture of the language model, either a BLSTM or a transformer. Second, in blue, the level of the language model, word, subword, or character. Finally, because language models are frozen in ELMO and FLAIR when learning the NER model, we study the feature-based version of BERT large where the language model is also frozen. As I mentioned in the introduction, contextual representations have been shown to improve performance on the standard NER benchmark CONEL 2003. But one key issue is still ignored: lexical overlap. The idea is quite simple. Some mentions we test our model on have been seen during training, and we propose to better measure generalization to unseen mentions by separating performance by mention novelty. We distinguish three types of mentions: exact match, partial match, and new mentions. We study this lexical overlap in the standard CONEL benchmark, and this enables us to measure generalization to unseen mentions. But we also want to have an idea of generalization to new domains. To do so, we train our models on CONEL and test them on two additional datasets, Ontonotes 5 and WNotes 17. We remap their tag sets so that they are aligned with the entity types in CONEL: person, organization, location, and miscellaneous. This graph represents the proportion of lexical overlap in different settings. First, in domain, on CONEL, Ontonotes, and WNotes. Note that the star refers to the datasets remapped to fit CONEL types. Then, in the out-of-domain evaluation setting, the overlap between CONEL train sets and Ontonotes or WNote test set. As we can see on both CONEL and Ontonotes, which are the two standard English NER benchmarks, more than half of the test mentions have been seen during training. This seems unrealistic for a real use case where we want to annotate the smallest amount of data and generalize to unseen mentions. On the contrary, the WNote dataset proposes a particularly difficult setting because we observe an overlap even between the news article domain of CONEL's train set and the user-generated WNote test. Let's now move to the experimental part. We compared 6 word representations: glove, glove plus a character by LSTM, ELMO 0, ELMO, FLAIR, and BERT, on the 3 previously described datasets. I invite you to read the paper for the detailed results, but in the interest of time, I will focus on ELMO's representations. The BLSTM language model in ELMO is not very different from the BLSTM in the NER model. Both enable to incorporate contextual information from word representations. Their main difference is in the way they are trained. In order to disentangle both effects, we introduce two settings to remove each of them. First, Elmo0 is the non-contextual representation of Elmo, which enables to remove the contextualization from language model. Second, we replace the NER by LSTM by a linear projection in the map-CRF model to separate the effect of NER contextualization. We do this for Elmo and not BERT or FLAIR, mostly because Elmo's representations are natively word level. Let's first look at the performance on CONEL of our non-contextual baseline map-CRF with Elmo0. As expected, the performance are far better for mentions already seen during training, either exactly or partially, which confirms the lexical overlap bias. We can now observe the effects of the two contextualizations. Again, quite as expected, both mainly improve the performance on new mentions and reduce the generalization gap to unseen mentions. We can also see that in domain, the NER contextualization is more beneficial. We can do exactly the same out of domain and observe the opposite effect. The language model contextualization learned on the more generic corpus is more beneficial than the NER contextualization, all the more as the target domain is far from the source. We can also see that both effects are complementary except on WNUT, where the user-generated domain is too far from CONEL's news domain for the NER contextualization to be of any help. In summary, we propose to better quantify the generalization capabilities of contextualized embeddings from language model pre-training. Our experiments show that they are particularly effective to improve generalization to both unseen mentions and new domains.